Perfect. Ajas, can we please let the attendees start joining us in? Requesting all the speakers to kindly mute themselves. Thank you. All the attendees for joining us. We'll just wait for 5 minutes more as I can see more attendees are joining in. Thank you so much for taking out time from your busy schedule and joining us today. Meanwhile, can we have the video being played as the attendees are joining us in? I suppose there was some connectivity issue. Can I request the video to be played again, please? Because there are some participants who have joined us now. Can I request?
Good morning, everyone. Good morning, Ivan.
Good morning, Bimal sir. How are you doing?
Good, good.
Good morning, Bimal sir.
Morning. Good to see you guys.
Same here.
Good morning, all. Good morning, Vimal.
Very good morning. Thank you so much, all the attendees, for joining in today. Welcoming everyone virtually to the webinar on design considerations for trackers and bifacial to achieve lowest LCOE confirmations. I would like to thank our exclusive partner, Arctech Solar, for joining us today. The solar industry faces challenges relating to the need to optimize resources with the aim of reducing the levelized cost of energy, that is LCOE. In this sense, solar tracker selection and solar tracker suitability for specific conditions of each site are paramount for project development. Solar trackers significantly boost the amount of electricity through constant orientation of PV panels towards the sun for the whole day. There is no other single balance of system that is BOS components that can boost a PV system's performance like trackers. Today, let us know more on design considerations for trackers and bifacial for Indian PV market to achieve the lowest LCOE. With this, let's begin with our introduction and opening remarks by Ms. Gail Chen, who is the General Manager of East Asia and India, Arctech Solar. Over to you, ma'am.
Okay, thank you, Sangeeta. Because Gail has some incident, she cannot join today's webinar. So just do a brief about myself. My name is Jason Wang, working for this industry for many years. Now I'm in Arctech, is handled the Indian sales business as Indian sales director. So thank you again, Sangeeta, for this wonderful webinar. And also thank you everyone to join this Arctech webinar. And today, as you said, our topic is design consideration for trackers and bifacial to achieve the lowest LCOE. Here I want to emphasize the LCOE. The lowest LCOE is always for every developers and also as well the manufacturers to chasing by. So here today we want to have some discussion about how to reach that. And also I want to introduce about the Arctech solar solutions, probably can help your future projects. Yeah, so Sangeeta, so can I have a brief introduction about my company to let the audience to know us better?
So you want the video to be played again, sir?
No, sorry. I want the PPT. Can we start?
Okay.
Hi everyone. Just want to give a brief about the Arctech Solar. So can we start now?
Can I share? Can I share?
Yes, please.
Okay,
yes,
okay.
Please.
Just a
Yeah.
minute.
Okay.
Just a minute.
Okay, we have next presentation on design considerations on trackers led by Bifacial by Mr. Ganesh Ray, who is the technical sales manager from Arctech Solar. Over to you, sir. You can start with your presentation and make the screen full, please.
So, Jason.
Yes.
You'll have to make it full screen, sir.
Yes. So now you can proceed.
Okay.
Yes. So I just want to give a brief about Arctech history. So Arctech Solar was founded in 2009 and our headquarters is in Kunshan City, which is very close to Shanghai. And in 2019, we have more than 800 employees working for this company. And in this year, because we have enlarged our team to reach more numbers of employees. And there's a cumulative 24 gigawatts around installation in global wide. There's more than 900 projects choose Arctech products. Ganesh, please, next slide. So some of a milestone and history, which founded by 2009. And in 2014, we have launched our first generation Arctracker Pro. And in 2015, Arctech Solar became the top 1 solar structure supplier in India. In 2016, we have become the top 1 in Asia Pacific, Australia, and China region, and the top 5 tracker supplier in worldwide. And in 2017, we have launched our 2P tracker, SkySmart. And in that year, we become the top 1 structure supplier worldwide. And
Sir, I'm
also
sorry to
check.
interrupt. I'm sorry to
Yes.
interrupt in between, but sir, I wanted to make the screen full, please. Please make it full screen, or the attendees are not able to see it properly.
Okay. Okay. So let me continue.
Sangeeta, now it's full or not?
No, sir, you'll have to make it full screen.
Just a minute, just a minute. Let me. Now.
You have to make it full screen. You'll have to take it in a PDF and make it full screen. Yes, perfect. Thank you. The
Okay.
earlier one you did. The earlier one you did.
Oh, sorry. Just a minute. Now.
I'm so sorry, attendees, to keep you all waiting. We are just setting up the screen. I'm so sorry about it. Sir, you'll have to make it full screen.
Ganesh, maybe let me try. Let me try to.
Okay.
Yeah. So can you see my screen?
Yes, sir. Now it's perfect. Thank you.
Okay. So let me continue. Sorry about some small incident. So I have introduced to 2017. So we have launched the SkySmart, which is a 2P tracker, and we become the top 1 solar structure supplier worldwide, and top 4 tracker supplier worldwide. And in 2018, we are very proud. We launched another 1P tracker named the Skyland. This is much suitable for the Indian market. So my colleague will give some introduction later on. And in that year, we keep our top 1 solar structure supplier in worldwide and top 4 tracker supplier in worldwide. And in 2019, we have upgraded our 2P tracker, SkySmart, become SkySmart II. This is the 2nd generation of the product. And also in that year, Arctech very proud to rank the number 1 tracker supplier in Asia Pacific area. And in this year, Arctech have a big progress. We are successfully IPO'd in China. And also we have secured gigawatt level solar tracker supply deal in India market. So you can see our friends have been touched every corner in the world. And we have in Arctech, we have 9 overseas branches in global, and 4 service centers, including India. In India, we already have 2 warehouses, and the 3rd one, which we are planning to set it up in Rajasthan, and for the purpose to provide the better service to our clients. We have more than 30 people local team in India, and this is not. And also, this we are planning to set up a technical center. It's coming very soon, because this we are thinking India is a very important market for us, and it's a very potential as well. So we will design some very suitable products, especially for the Indian market. Now we are not only supply tracker services, we are also doing the installation services. And in 2021, we will launch our robotic cleaning as well. And this is show our factories. We have 3 factories, which is located in Changzhou, China. That city is close to Shanghai as well. And the factory 3 is a brand new factory with gigawatts capacity and fully automated production lines. We are sincerely invite you if you have interest in and come to China and visit our factory. And about us in India, we have already commissioned 850 megawatts Arctech Pro and 350 megawatts Skyline products. And also because 2P trackers cost is quite high, so we commissioned only 2 megawatts 2P trackers. And in this year, I have mentioned in India, we have under construction 1 gigawatts with our Skyline products and Bifacial. So next slide, I will invite my colleague, Mr. Ganesh Ray. He's the Senior Technical Manager from Arctech Solar. He will give the he will give the introduction about our products and technicals. Thank you. Ganesh, please.
Yeah, so thank you so much, Jason. And good morning, everyone. Thanks for being here today. And I'm Ganesh and looking after technical sales support for this India as well as Middle East market. So today I'm here to discuss about our product line as well as technology. So other than this product technology, we are going to discuss what things we are considering in our design, especially for the bifacial module. So Jason, if you want, can I share my screen? Because that will help me to smooth in the right way. Jason, SQ team, can you please help me to share my screen? Sangeeta?
Yes, sir. I will give you. So the request is given to you. Please
Okay.
go ahead sharing your screen.
Okay.
Jason, sir, can I request you to stop sharing your screen, please?
I have stopped.
Okay. Okay, Sangeeta, please confirm. Is it completely fine, or I need to do some?
Visible, but you'll have to make it full screen, sir.
Yes, now?
You have to make it full screen, sir. I don't know. There's an issue with your system, I suppose. It's better Jason sir shares from your end, or yes, now it's perfect.
Okay, okay.
Before
great.
this, it was perfect, sir. You did again something.
Sorry.
I'm so sorry, attendees, for keeping you all waiting. No, sir, it's not fine.
Now?
Yeah, now it's fine.
Okay, thank you. So sorry, guys. So basically, we have 3 major products, and we are the only company in the world who have both the architecture 1P and 2P, and we have around more than 1 gigawatt installation already in around the world. And our main product is Skyline 1P solution, and other than that, we have 2P solution as well, which we call the SkySmart and SkySmart II. And in the further slide, we will discuss more about this 1P and 2P tracker. So this is our flagship product, which we call the Skyline. So these are some special characteristics of this Skyline. So we launched this product in 2018. And after this 2018, we have seen there's a huge demand about this particular product. So this is our flagship product, and in around the world, we supplied more than 2 gigawatt of this particular product. So here for Indian market, we are using 1V5 controller, which help us to reduce the price drastically. Other than that, we are using here D type of tracker, D type of torque tube. Because of this D type of torque tube, this will give us a high reliability to put the module in the flat surface, because bottom portion is circular and upper portion will give us a flat surface. Other than that, here we have a higher GCR capability, north-south slope up to 20%, And here we have a LoRa communication provision. Our next product is SkySmart, which we launched in 2017. This is our first 2P solution. So this is especially designed for the bifacial module because we learned from many of our prestigious clients. They are saying if there is a torque tube in the mid of module, there is a chance of shadow. So especially we designed this for the bifacial module, but in the further slide, I will explain you that is a myth where people are saying 2P is generating more in compared to 1P. So we have installed both the product with bifacial solution around the world, and we have seen there is no major generation difference in 1P and 2P. So this is our first 2P solution, which we call the SkySmart. And next is SkySmart II. This is our latest product and advanced version of our SkySmart. So here we have basically multiple slew drive solution. So basically we have many fixed point and many cantilever in spans. So this will give us capability to accommodate longer size of module, because nowadays we have seen module size are increased drastically. Earlier we have around 1956 and 992 module dimension, but in recent days we have seen module dimensions are reach around 2.3 by 1.3. So this particular model allow us to install these kind of modules easily. And other than that, in this particular model, we have capability to accommodate up to 4 strings of 1500 voltage. So let's assume if you have a 29 or 29 or 28 module per string, so easily we can accommodate up to 4 strings in this particular model. So these all are some design consideration in our 1P and 2P solution. So as I mentioned in my last slide, in 2P solutions, we have a distributed slew drive, and here we can accommodate 4 string. And other than that, here we are using all H beam, because this cord length is very long in this particular model. For the design consideration, we must need to consider all H beam. And square tube is here square, torque tube is here square, and stowing angle is 0 degree. And next critical parameter which we considered here, excess height around 2.2 meter, because cord length is more. So to accommodate this additional cord length, we need to increase the height. So we consider 2.2 meter. But if client have a special requirement, we have provision to customize this as well. Along with this, in 1P solution, our excess height is around 1.3 meter only. And purlin, we have provision to consider additional purlin height as well, because that is a very important consideration for the bifacial. In bifacial, we must need to consider some additional purlin height to generate more. This is the comparison which we carried out, one of the site located in southern part of India. So we run PVC simulation in for 1P and 2P, and we have seen if fixed tilt is generating around 1671. So if we install bifacial module in the fixed tilt, maybe generation is hardly 3 to 4%. But if we compare tracker monofacial and tracker bifacial, there is a difference around 23 to 24%. So here we can say if you are getting around 13 to 14% additional from the tracker point of view, additional 7 to 8% you will get from the bifacial point of view. So easily you can get 23 to 24% additional if you use tracker plus bifacial solution. So these all are some considerations which we consider in our PVC, which we have considered 6 meters for the 1P and 12 meter for the 2P. Similarly, excess height 1.3 and 2.6. And these all are some losses. So rear siding losses we have seen that almost same, 2.74 for the 1P and 2.71 for 2P. So there is no major difference. There is no huge difference in the generation gain as well as near siding loss. So this is the study which we carried out in Madrid, and this study we especially carried out for the bifacial gain, because we have seen many of the clients are asking us why you guys are considering only 60 to 70 additional purlin height. So we did this study and we found uh, uh, this 60 purlin, if we use 60 purlin, automatically module height is around 100 So in this study, we have seen this generation bifacial gain will increase only up to 100 If you use this, if you use more height for the purlin, there is a chance of shadow. If you see this portion, so here, just a minute. So if you see this portion here, shadow will occur if you increase the height. So if you consider lesser height, there is no chance of shadow. So that's why, as per this Madrid University recommendation, we are considering only 60 height. And with this 60 height, easily we can get around 100 total height, because 35 to 40 is our module frame height and 60 is from purlin. So easily we can get 100 and there is no chance of shadow. This is another study which we carried out from the same university. So here we have seen basically in 1P and 2P, if we consider tracker height around 1.5, so basically in both the tracker generation numbers are same, because if you see here, the difference is only when tracker heights are less. But when we consider the same height, 1.5 for 1P and 3 meter approximately for 2P, there is no difference in the generation. So that's why in 1P solution, we are considering same height. And another study we carried out in the same university, what kind of torque tube is better for the bifacial solution. So in this study, we have seen, of course, round type torque tube is better, but D type is also doing great. So here, if you see this blue color line, so up to 12% gain you can get if you consider the D type torque tube. This is the our AI controller, which nowadays we are using in all our projects. This is we implemented last year, and now whatever products we are supplying here, we are using AI controller. So in our latest AI controller, we are using a asymmetric backtracking algorithm. If you see this first picture, in the morning and evening hour, there is a chance of shadow, because on that time shadow length is longer, and so whatever trackers are in the lower hills, there is a chance of shadow. But if we use this AI tracking algorithm, asymmetric algorithm, so all the trackers are independent at different angle, and there is no shadow occur. So that's why nowadays in all our projects, we are using this AI technology. And due to this AI technology, if your land is very much undulated, so you will get around 0 to 4% additional gain. This is the advanced version of AI controller. So basically here we are using some device which can take the cloud images and project these clouds in a photovoltaic plant. Meanwhile, we also involve the real-time metronome data, and we compare the actual cloud versus whatever is available in the field, and we project the plant, and we put this cloud sensing observation in our actual plant. So this kind of technology is very useful, especially for those regions where heavy rainfall will occur, like in India, in Kerala and some of the western states. We have seen around 6 to 7 months yearly there is a rainfall, and because of this rainfall, there is a chance to huge generation loss. To avoid this kind of generation losses, we have this provision which we call cloud strategy, and this will allow us to give additional gain 0.5 to 2% on those days. So this is a self versus string powered. Nowadays, we have seen many of our competitors are offering a self powered solution. But there's a big problem when we consider self powered solution, because if you use self powered solution, you need to rely whole your 40 to 50 kilowatt of power generation in one small module, one or two small module. So you all know, you all are aware, these small modules are not reliable, because anyway, for a bigger module, you evaluate everything, but smaller module, you don't have capability to evaluate each and every point. So you cannot rely 40 to 50 kilowatt in this small module. Other than that, you also need some additional space to accommodate these modules. And if you use this small module, there is a chances continuously you are taking power from the battery. And if you use continuous power from the battery, automatically your battery life will decrease. So that's why in our solutions, we have a string powered solution. Here in your existing string, we are taking power from your nearest string through the Y connector, and we use that power as a primary source. For the backup, we have a battery as well. And since we are using less power from the battery, there's a less charge and discharge cycle. So automatically battery life will increase. And in our solution, we have a battery life around 10 years. This is the solution which we called string powered. So basically this is your 29 or 28 module per string, complete string. So in your string output, we are going to connect these two Y connector, one in positive, another is negative. One output will go to your control, your inverter or your SCB, string combiner box. And another output will come to our tracker controller. And here we are going to use this kind of Y connector. So this we call string powered solution. Other than that, in our trackers, we are using LoRa, which is long range and less power technology, advanced version of Zigbee. So this technology is mostly used for outdoor environments such as field and farms. So we have seen in this LoRa technology, range is approximately 8 kilometers. So easily we can accommodate more tracker within the same range. And here current power consumption is very less in compared to Zigbee. And the one more advanced feature in this LoRa, here range is approximately 8 kilometers. But again, to use this LoRa technology, no need any additional license or something, because it's run only 865 to 867 megahertz of frequency. So this is again license-free technology. If you use this LoRa, no need to take any additional license from the government. This is our tracker communication architecture. So basically, as I mentioned in my previous slides, so in this solution, we are using 1v5 controller. So in each 5 trackers, in the center row, we have a additional power box and battery. And this power box and battery will give power supply to all the 5 trackers. And rest of the 4 trackers, we have only controller, motor, and inclinometer. And this power box and battery will give supply to the all 5 trackers. Similarly, we can connect up to 149 controllers with this single communication box. This single communication box is capable to control all 149 controllers. In this communication box, we are going to connect this wind sensor. Wind sensor will give signal to the communication box. And at the end, this communication box, we will connect to SCADA. From the client SCADA, client can monitor and client can control overall the plant. So this is the architecture. Other than that, this is very important parameter, which very important quality in our trackers, because nowadays in India, we have more and more undulated land. and it's very difficult to accommodate the capacity if tracker have less slope adaptability. So in our tracker, we have around 20%, or we can say 11.3 degree north-south slope adaptability. So this will allow us to accommodate more capacity, especially on those regions where slopes are more. So this is a very advanced technology which we are using in our tracker. So basically, in the bearing pedestal, we have provision where we can tilt whole torque tube up to 12 degree. This we call lower GCR. So basically, we have seen our most of the competitors have gap in top of the post, and due to that, automatically their GCR will reduce, because if you see in the right side picture, competitors are not going to put module in the top of the post, and due to this space will empty, and you are not able to accommodate more capacity. So that's why we are seeing our GCR is approximately 2% higher, and this will help IPPs and EPCs to save land and cable costs. So if we compare 90 module tracker, our competitor's tracker length is approximately 98 meters, but our tracker length is only up to 90 meters. This is our robotic compatibility. So we already carried out this robotic compatibility test with 8 major companies available in China. So all these 8 robotic companies we have seen, all trackers, all our models are compatible with this solution. So basically here we have seen how exactly this docking station and bridges we need to connect, and how these trackers will perform along with the robot. So we already carried out, we have 3 to 4 test beds available in our factory, and all these robotic suppliers we already tested in our factory. So this is the testing. It's look like this. So this is the bridge part. And this is the motor part. So bridge part is more critical in compared to motor, because anyway, from the bridge you need to jump from one tracker to another tracker, but easily you can jump from tracker to tracker along with the help of bridges. So this we carried out in our factory. Okay, so with this I will wrap up my presentation. And if you have any further questions, so maybe at the end of this session we will discuss whatever questions you have, and I'm happy to answer all technical questions, whatever is related to this presentation. So thank you everyone. Thanks for hearing me. And now I will welcome Mr. Amit Harekar. He will help you to understand more about CAPEX and LCOE. Thanks everyone. Now floor is yours, Amit.
Thanks, Ganesh. Can you please stop sharing your screen?
Yes, please.
Thank you. Very good morning, all. Thanks for joining our webinar, and thanks SQ for the organizing this wonderful webinar for us. And thanks for the panelists as well. So I start my presentation with the case study, which recently Bloomberg has done analysis on the historical low tariff, which we all seen in India in last month. So the lowest tariff rate was quoted by the all international developers. That was 2 rupees for per kilowatt hour. And we observed that it was, big surprise for the Indian developers as well as for the all BUS suppliers, because India is a very challenging market, and in India, you can achieve this price only with the bifacial and tracker. So you can see in this picture, some of the bidders were considered and did assumptions, so they can go with the bifacial and tracker for this bid, considering the lowest LCOE in future. So as you can see, most of the bidders, they analyze that in Q2 2021 or Q3 2021, maybe the model prices are going down, as well as the steel prices may go down, and there may be a possibilities, they can reduce their capex, and they can achieve the lowest LCOE in that case. So even we also have a very successful tracker one in India in this year, as we are supplying around 1 gigawatt bifacial tracker in India, in Rajasthan region, in 4 different site locations. And we strongly say that, yes, this lowest price can be achieved only with the bifacial tracker. So there are, couple of factors that going to influence your bifacial gain. And while designing a plant, you have to consider few parameters. And as Ganesh already mentioned to you, 1P or 2P, is it, suitable solution for bifacial? Then I would say that yes, both are suitable, but it is depend upon the site conditions. So if you are looking at a plant in India, so in that case, you can go with the 1P as well as 2P. But I would say in Rajasthan region, we strongly suggest to go with the 1P solution, because in Rajasthan region we have a very high wind speed, and that wind speed, going to influence on the tracker cost, because the weight of the structure going to increase in that case. So as you can see in this picture, so the major factor which is going to influence, that is the ground albedo, then height of the tracker, and the pitch. So the first picture you can see, as you know, in 1P solution, the albedo is also very important, as well as the pitch, which you consider for the designing of a plant. So the diffuse rays, that is going to reflect to the backside of the module, as and when you have optimum pitch consideration and optimum height of the tracker. So whenever some people, say that the tracker height should be, 1.4 or 2.4, then only we can have a greater albedo, because the reflections rate are higher side and there is no shadowing from backside. But I would say in that case, whenever you go for a increase in height, then there will be a shadow projection more on the ground, and in that case you have to create a more pitch. So, and that creates, the additional burden to the developers for procuring a land. So according to our understanding and experience in India, on 1 gigawatt scale of project, so we understood that the optimum height of tracker should be, 1.3 meter from the backside of module, and the optimum pitch you can consider that is a 5.5 meter. And if you consider those parameters, then only, you can achieve the lowest LCV as well as the lowest capex compared with the fixed tilt. So this is the comparison we have prepared for this webinar, and considering the overall, increasing capex with the fixed tilt and with the uh, bifacial and tracker. As you can see, for the fixed tilt plant, if you aiming for a particular megawatt hour generation numbers, then that same generation numbers can be achieved with the bifacial and tracker, with the lowest DC capacity or with the lowest DC overloading. So we have seen here the major role, play in this capex is the module price, because this is the only driving factor, which is going to increase your capex. Whereas the other BOS part is, that not make any huge difference. But if you only consider the structural cost or the fixed tilt structure cost versus tracker cost, then you will not find out, the lowest LCOE. So I have done a comparison for the fixed tilt and the tracker with the bifacial. So whereas we observe that the decrease in capex with the bifacial and tracker is approximately 11%, and that leads to, to achieve a lowest LCOE. So we have done some assumptions here in the designing of a plant for a fixed versus tracker. In fixed tilt, I have considered the 45% DC overloading, and I have considered some constants, like I have considered the constant land requirement for the bifacial with tracker and bifacial with the fixed tilt. So this part I will show in my further slide here. So as you can see, if I want to install a 50 megawatt plant with the 45% of DC overloading, then in that case, I require a 2.5 acres of land to install 72.5 megawatt peak. Whereas in case of bifacial and tracker, I required 3.3 acres per megawatt land to achieve the same generation numbers, which is being achieved by the fixed tilt system. So if I do a comparison versus what is the DC capacity, what I'm putting up on a ground, in that case, the overall, if you multiply with these DC numbers and the land requirement, then you arrive with the same land requirements. So as you can see, the land requirement for the fixed tilt is around 181.25 acres for the 72.5 megawatt of a plant, and for the bifacial and tracker, you have a requirement of a 184 acres. So it's more or less same. Apart from that, in DC cables, up to inverter, if you choose a string inverter or if you choose a central inverter, the DC cable length you are saving in the tracker with bifacial is relatively very low. It's relatively, it's, you can say, more or less it's the same in that case. So you're not going to, pay more money on the DC cable cost. Moving back to the my comparison, because I have not considered the other BOS cost in my calculation, because up to inverter there are increase or decrease in capex cost, and after inverter to your transformers, there will be a fixed cost which is going to be similar for the bifacial and tracker, plus we can say for the fixed tilt system. So from my analysis and from my understanding, we arrive with the numbers that is, we have a decrease in capex around 11%. And if you calculate the NPV based upon your power plant, if based upon your plant, then yes, definitely you will achieve the lowest LCOE. And we have proven that with our successful track record in India, as we have sign a deal in India for a 1 gigawatt, and this year we are supplying around 1 gigawatt with the bifacial and tracker. Yeah. And from this, I end my presentation. Thank you very much for listening.
Thank you very much, sir, for the valuable insights. With this, we will proceed ahead with the panel discussion with all the speakers who have joined us today. We have session experts, Mr. Bimal Jindal, who is the Director HCM from SD Energy. We have Mr. Ivan Saha, who is the Chief Technology Officer from Renew Power. We have Mr. Sudeep Pathak, who is then Head Engineering from Hero Future Energies, who will also be moderating today's session. We have Mr. Sai Charan, who is the Deputy Director from Jinko Solar. And we have Mr. Jason, who is an India Sales Director from Arctech Solar. I would like to hand over the session to Sudeep sir to take it forward with other speakers. Thank you.
Hi, thank you, Sangeeta, and good morning to all and my fellow panelists. So, hi, very good morning to all.
So before we proceed ahead with the panel discussion, I would quickly launch few polls for the attendees. So attendees, here comes your first poll. Do you think with ₹2 tariff coming into consideration, will IPPs achieve maximum benefit with tracker plus bifacial? I'm closing the poll now. So 47% of attendees agree to it. Thank you all the attendees. Here comes your second poll. Do you think bifacial gains will be the same for single port tracker and double portrait tracker? I'm closing the poll now. 33% of attendees say no, wherein 32% of attendees say yes. So attendees are a little confused. Thank you, attendees. Do you agree to the fact that design life of tracker is 25 years? I'm closing the poll now. So only 48% of attendees agree to the fact that the design life of tracker is only 25 years, wherein 44% again disagree. So I believe Arctech team will be able to solve this query. Here's the last poll. Do you think trackers are compatible with robots or not? I'm closing the poll now. So the clear-cut winner over here is yes, with 65% of attendees voting for it. Thank you so much, all the attendees. Over to you, Sudhir, sir. Thank you.
Yeah, thank you. So we can start we have gathered here to talk about a very relevant topic, and which is like kind of created a kind of blitzkrieg, 2 rupees, and now everybody, all the developers, including and EPCs, now they are sitting in their drawing board and making a lot of calculations in Excel and PVSist and so many things, calling so many people to tell about the magic. So, so I think this is the apt time when we can discuss this point, and that too, especially after such a wonderful presentation from Arctech about the product. So, although I agree that the tracker was a kind of slightly lost issue as far as India is concerned in the recent past, but this has suddenly gained a traction because of the new history which has been created. So as we are talking about LCOE, so as we all know that LCOE has two major components. One is obviously numerator and another is denominator. So numerator is the cost, the capital cost and the OPEX, and the denominator is the NPV of your generation. So definitely the panelists which are here, so we have the experience of trackers, like in Hero Future, we have lot many trackers we have, and even in Renew, I think we have a lot of trackers. I think Bimal is also, he can tell some experience about the trackers. To start the discussion, let me set the base slightly. Okay, the trackers are really very good as far as generation is concerned, increasing the generation specific yield output on paper as of now, as I believe. There are several reasons behind it, as has been discussed. That first of all, that it is a purely mechanical device, right? So it's a mechanical device. It has to move 24 hours, not 24 hours, so maybe in the daytime and 365 days. So being a mechanical device, so it needs a kind of maintenance which may more be needing maybe less for the fixed tilt. So I'm just trying to challenge, right? So that's my objective, to challenge and then keep my panelists, my August panelists, to express about their experiences on that particular perspective. So first of all, that trackers being a mechanical device, and so there may be some maintenance need, there may be need of uptime, right? So uptime, that will come in the denominator for generation, and the maintenance will come in OPEX, which is in the numerator. Second is the capital cost for making these things, which is definitely have a differential as compared to the fixed tilt. So giving these broad 2 points, and the third point is like definitely as Heriker was explaining about 2P versus 1P, and even Ganesh also, that like typically Badla zone, where you have basically a high wind speed. So right from 45 degrees to 0 degrees, typically trackers are designed from stow angle to 45 degrees for the lower wind speed. So how do we perceive that when it moves to the stow angle, the stability of tracker will remain there, will not fail? And the third thing is definitely like my friend from Jinko is there. So about the bifacial, because bifacial, unlike monofacial, it has huge bearing upon the land which we are going to use, and also the PVC's tool which we use. Like typically we have 2 or 3 algorithms about how the diffusion is being taken care. Like view factor algorithm is there. There's a ray tracing algorithm. So PVSys is still in the mode of learning curve, wherein how to ensure to correctly take the albedo and also the back shadows, like what Ganesh told about the torque tube shadows. So rather than speaking more on this, I will now request that first I will ask Evan Saha, because I know that you also have a lot of tracker experience in your portfolio. So right from history to the future, what is your history and what is your wish list in which we are very clear that okay, now this is really going to work on the real ground? Yeah, over to Evan.
Yeah, thanks. Thanks, Sudhir. So, yeah, so Renew has been one of the earliest adopters of tracked systems. And I think we have more than 3 years, last 3 years, we have installed tracked systems. So obviously, we have gone with the most popular ones. Arctech is one of them. And what we have seen, and these are in Rajasthan, in Andhra and other places. So what we have seen is that all these systems have been with monofacial. There is no bifacial. There was no bifacial since 2016, 2017. So all these systems, they have fared compared to fixed tilt, anywhere between 12 to 15% additional generation has come. Okay, and whatever our estimated LCOE gains that we had estimated at the start of the project, that has been achieved. So the estimation has been quite accurate, and that's the reason we have been quite optimistic about the future of tracker systems. However, the difference at that point and the difference between 2016-17 and now is that there has been a substantial reduction in module cost, module price. And at a point when module price was at the level where it was, I mean, 3 years back, and to now, where it is less than 20 cents, the dynamics, the cost dynamics, the LCOE actually changes a lot. All of you know that. And module cost is a primary driver for trackers. However, now with bifacial and larger size modules, 600 watt peak, 550, 600 watt peak coming into picture, I think, so in between tracker had lost out a little bit, lost out of favor, because there has been, since the module price reduction was so aggressive, therefore, tracker advantages actually did not play out that way. So now that the module prices are around 20 cents, less than that, and going down further, but the sizes have increased and bifacial has come in. Now, factored all of that in, of course, with size increase of the module, there is also the weight increase of the tracker also has to be considered, and the amount of steel that goes into the tracker. But I believe tracker technology as of now still requires, with bifacial gains factored in, larger trackers, and still requires a kind of a significant amount of price reduction from the present price points in order to make the whole tracker plus bifacial large module solution attractive. So to that effect, now I think what we are planning to do, we are planning to deploy a few pilots with this exactly the same concept of bifacial large size modules tracked 2P, 1P, 2P configurations, and trying to with different pitches, like starting from 8 meters to 10 meters to 12 meters, and trying to see what makes sense and trying to understand, because this is probably the first project where we are going to deploy this will be commissioned by February actually. And there would be a few pilots in that project also as a part of that project. But then going forward, depending on the results that come out of it, we'll have to take the decision or the call.
Yeah, thanks, Ivan. So I think that was well said. With the reason being that, so I like the takeaway from your thought process is like, first of all, since again I'm reiterating that the tracker being a completely mechanical device, keep on rotating here and there. So so we need a real partner who can on whom we can rely upon, because we have huge number of tracker manufacturers here and there. So we need to see that who on whom we can bank upon, who have really done the like wind tunnel studies, and they have developed their tracker suitable so that they can ensure the uptime through some contractual obligations and all those things, number one. And number two, yes, you are completely correct that being bifacial, it is very important to have touch base. So without pilot, we can't gain the confidence that just really the albedo is this much. This is the quantum of diffusion. So that will give definitely a real sense that yeah, definitely this is going to give the gain, because bifacial gains of maybe even change of 5 or 6% may change your LCO like anything.
Absolutely.
That is going to, and with these tariffs, with such a thin IRRs, so changing of 5% difference will create the complete business case as a failure. So that point is well taken. So like as you were talking about the cost, so who else better can say other than Vimal about the cost and all those parts? So so Vimal, I wanted to understand your take as far as this new jargon has come out, bifacial with tracker. What is your take on this?
Thanks, Sudhir. So I think it's an interesting topic, and I could not agree more. What Ivan said. I personally did more than half a gigawatt of tracker in the initial years. The 13, 14, 15. Then the module price were pretty high. One of the factor which as an industry, I believe everyone is watching. The module price has reduced from 60 odd cents to 20 cents. So if you look at the reduction, I'm just talking the ballpark number. It's like becoming 35%. But if you look at the tracker, I remember those old days. These were 13, 14 cents, and even still, we are talking about close to 9, 10 cents or whatever number, depending upon. And again, that is coming mainly because of the efficiency of panels. So the tracker guys were not able to do substantially any innovation or any improvement which can give that kind of action which has happened in modules. I'm not saying that it should happen there, but if you look at the industry, all the components, whether it's modules, inverters, everything, the cost has come down. Now, in case of trackers, everyone understands it's a structure, and the steel prices are always going up, so that is one of the concerns. But again, the tonnage of tracker has substantially come down, but the prices have not come down. So that is one of the concerns, which I believe is holding up the industry to still go with the tracker. If you see in last, like Ivan said, last 2-3 years, people are not bullish on trackers because they're feeling that they can put more modules and they can get the better generation, which is guaranteed. In the tracker, again, the variation of 10 to 20% with the different. I was just looking at Amit's presentation. He's saying that with bifacial, it can go as low as from 1.45 to 1.12. So I still don't understand the maths. Sudhir, you are expert in that. Maybe you should give your views on that how that will reduce this much. But the way I look at, I believe industry is looking for the innovation and technology. The tariffs has come down to the 2 rupees level. It will not happen just with the simple negotiation or discussions. Now, the way module prices are reduced, the tracker prices also need to go in sync. I believe the internal studies has been spoken. So like you said, so that part I believe is lagging. At least the way I look at the many of the countries are doing it. I heard about 1P and 2P. It has I believe as a developer, all of the developers are agnostic whether it's 1P or 2P. It's the LCOE which matters. Now, like you rightly pointed out, I heard in the presentation also, there are a couple of factors which matter. In India, the first factor, we are the lowest BOS cost country. So when you go for 2P in many of the countries, because we have worked in many other countries, the way I look at the way you go to 2P, you want to reduce the number of foundations. That is also one of the criteria. In India, the costs are pretty low from the civil perspective, so that is not one of your criteria. The second part is the wind speed. The wind speed is very, very critical. In India, especially in the Rajasthan region, the wind speeds are so high, it cannot take 2P. The structure will go so high, which is the highly, inflated commodity. Sorry to use this kind of word, but the way I look at, so this is going to play a critical role. The third, you also spoke about the stowing of the tracker with 2P. At high wind speeds, stowing of tracker with 2P is also not easy. The third part, which we are missing, the modules are talking about 500, 530, 600, but it's not a simply efficiency gain. I believe, Sai may be able to add, but it's, some cheat code, I call it. So it's a mixture of, and Ivan is there, he's the expert in modules. It's a mixture of efficiency and then the size. The size is playing a bigger role. When you're talking about 530 or 600, even I heard in SMEC people talk about 800 watt, 790 plus watt panel. So I was going through the specs and details. I found that it's more of a size change. It's not the efficiency is becoming from 20 to 25 or 30%. It's not happening. So basically, for the tracker guys, the efficiency matters. It's not like you simply say it's 500 watt peak panel, the tracker cost will come down. So all these factors are going to play critical role. The way we are looking, the module markets are moving towards bifacial. That is one of the big drive which is happening in the industry. So if the market is moving to mono and bifacial, that is going to be definitely going to give a good competitive edge to the developers. Another factor for consideration of bifacial, previously the delta between mono and bifacial was very high. So the poly to mono, I'm just talking about the old numbers, 3 cents, and then in poly to bifacial, mono to bifacial, it was another 3 cents. So it was 6 cents. Now we are talking about mono and poly going to become at par. I'm not going to talk the issues which is happening in the industry for the timing, but the way it's work. And then again, bifacial and mono, again people are talking about a very minuscule delta compared to the old days. It may be under 1 cent, the way people are looking at. So I think these are the factors which are going to drive, because the gain of bifacial may be able to offset the delta of mono versus bifacial. The second part is the efficiency of panels, which is going to drive on the tracker side. Now the tracker, again, we need to see how that will turn up. The reliability is another concern, which as a developer you need to see. The 25 years of operation with tracker versus fixed yield is totally different. You have to spend so much of time. Sometimes the trackers can break down. Again, it has the, like you rightly said, it's having moving components. Plus, it has electronic components also. So everything need to be seen, and again, it need to driven by the SCADA, which need to be 100% up. In India, we are still going to that level where the internet is not available in the remote location. So if you want to operate with the SCADA and give some kind of I would say arrangement, it's still going in a good pace, but it's not the pace which you expect. If you're talking about gigawatt scale project, you want the project to happen. So there are multiple challenges, but I believe it's going to the future, the way industry is driven. Only the timelines need to be unknown. I'm I'm personally aware that monofacial was supposed to be available in 19, the way people are talking. Now it's a reality after end of 2020. In the 21, practically we're talking it's available. But whenever we're talking the manufacturer in China, they were talking about 19. The mono is going to be there. So we need to see the bifacial. They're talking about 21. Where it's going to be really 21, it will be 22. I leave it to them how they want to drive the market.
Thanks, Vimal. As usual, you provided like very great insights and your varied thoughts. So, like, I will try to bring take people a few years back, wherein about inverters. Okay, so with string inverters and center inverters, there were a lot of thoughts that about SLAs, that because inverters are full of electronics and you don't expect the O&M people to go and troubleshoot. So out in the O&M contracts about inverters, it was one of the biggest SLAs. What is your uptime? In how much time you will respond? Your MTTR, MTBF. So I think like what Vimal rightly said, that being a mechanical device and also electronic device, so the service chains of the tracker manufacturers has to be robust, because whatever we given writing, it is definite that whatever is mechanical, that is bound to fail with the time. It needs repair and maintenance. So for ensuring that we get the right kind of uptime, because tomorrow if anything fails, the major problem is going to be to the developer, because everything are their stake. So that is very important point, as Vimal rightly told. So for that I will come to Arctech on that part. Before that, so Sai, as Vimal has given a cue regarding the module cost differential, because in the Excel file of LCOE, as you put one USD cent difference, your economics go haywire, right, of the modules. So I have two questions from you. First of all, that what do you perceive the bifacial to monofacial cost difference, in how much of time frame is it going to subside and going to go slightly to a parity? And point number two, that yes, this ghost of bifacial gain, which is lingering around everybody, and everybody creates an own Excel file, assume the albedo. Just for example, if you take Saudi Arabia, just if you go through the Google Earth and create a screenshot and show your Saudi Arabia and Badla in the same screenshot, you will automatically make out the texture is totally different, right? Saudi Arabia sand is very shiny, very bright, and Badla. So people typically make a mistake by simply copying the Saudi Arabia example to Badla. So my question to you is, number two is that what is your, has Jinko done some kind of POCs in their own works to ensure that what kind of gain they will be going to get for different texture of soil, right? So Sai, over to you.
Yeah, thanks, Sudhir. I think, yeah, now it's time for the entire market to look at this kind of bifacial technology solutions with advanced optimized materials, just to get lower LCOEs and to get better IRRs. So specific to your concern, wherein which what even Mr. Bimal has raised, the points of whether the parity is going to happen, just what has happened with poly and mono on the monofacial side. If we just try to see that particular segment, now entire manufacturing capabilities of the entire globe, that has been shifted towards monoPERC technology only. So out of 150 gigawatt capacity of global demand, we could see close to around like 130 gigawatt capacity is being manufactured only on monoPERC. And poly is completely getting diminished with less than 20 gigawatt kind of capacity across the globe. So now the point comes is like monofacial versus bifacial within the monoPERC kind of technology. If we just try to see, yes, there is a kind of slight gap, which is what is there. The delta, what you are asking, Sudhir, is like the delta is there. That's all because of the processing of that particular module manufacturing. But if you just try to look at the cell manufacturing process, it's the same cell now people started using for both monofacial and bifacial. So the components are the only change, which is what is happening on the encapsulant, or if it is going with the kind of glass to glass kind of modules, the extra glass is getting added. So barring these two particular components, if you just try to see, rest everything is going to be remain same. And on top of it, you'll be having a kind of extra gain or extra warranty specific to these kind of bifacial modules, where in which that will be coming for 30 years with better degradation because of the encapsulant, which bifacial modules always try to use it. And the second other point where what Mr. Vimal is trying to touch upon is its only size of the module is getting increased with better power class. Yes, in fact, on one side of the industry, that is happening. But yes, also a slight variation in the efficiencies specific to, if you just try to see the market conceptualization for the last 2 years, if you just try to see, market always used to follow as a standard product of 158.75 wafer size, and then people started moving towards 163.75 and 166. At one point of time, it has become a kind of standard product for most of the module manufacturers. And now the game is between only two, 182 wafer size or 210 wafer size. So with the shift of these kind of wafer size, just increasing the wafer size from lower size to bigger size, a lot of optimizations are also happening on the same thing by just going with multi-bus bar, where in which low irradiance loss factors are getting reduced, and trying to increase the kind of specific energy yield within the same technology of monoPERC. So optimization is happening where the CTM is getting reduced within these kind of high efficiency, high size, high power class modules. But yes, eventually if you just try to compare the initial monoPERC technology, which was standing at 19.2% efficiency, and now the recent or the existing 182 wafer size kind of modules, which are standing at 21% kind of efficiency. So the change is not so drastic, but yes, there is a change. But that definitely is going to add much more value on your LCOE calculations. And to the part of your second question, where in which what kind of albedo factors to be considered, and at what different albedos, what kind of gains can be assumed. So specifically, yes, we have done similar kind of analysis within our factory, Henning factory. Also, we have got many reference-based installations across the globe. And what we have noticed is that albedo, depending on the texture, definitely that varies. And that always follows, it's not going to be constant throughout the day or throughout the year. It also follows the same diurnal curve, exactly opposite to the bell curve of our existing irradiance curve. So what generally, but what we can consider with this particular aspect is, we can consider the average value as what we always try to capture in our algorithm simulations of PVsyst. So that is possible to capture as a kind of base value, where even we can even measure that particular sensitized value of albedo factor specific to site location if we have 2-3 different climate sets of data. So that is even possible to capture. But specifically, if we just try to see comparing sand, like Israel sand is one kind of sand which is having yellowish factor of very high sensitivity when compared to Southeast Asia, yellowish factor. And similarly, specific to Badla or Bap or Rajasthan kind of locations with Jaisalmer, if we just try to see the yellowish factor, bit different. So specific to that, if we just try to see specific to our locations kind of thing, where the albedos of our region generally stands in between, if it is a kind of desert kind of location, it always stands in between 25 to 28% kind of thing. But the major important factor, what we always try to look at is all these kind of utility scale projects. They always try to come on either on the barren land kind of thing, or more of kind of areas which has got low soil moisture content and low thermal resistivity. The places whichever has got low soil moisture content and low thermal resistivity, they are high prone to have high reflectivity sensitivities, which means they always will have good albedo factors, which is why we could see not just limiting only to the locations of Gujarat, Rajasthan, or a few patches of Karnataka and AP and Tamil Nadu. It can be used at any kind of location whichever has got low soil resistivity and low thermal sensitivities. So for those particular locations, always these kind of bifacial technologies makes much more sense, where in which the entire bifacial factor of these kind of modules, which is standing at close to around like 68 to 72%, it always can be utilized. And that sensitivity always will help in getting higher specific energy yield. And specific to different albedos like 20%, or if it is a kind of green vegetation, we always can expect on a kind of fixed tilt mechanism. If it is a 15% kind of albedo is there, you easily can expect 4% kind of gain. And if the albedo is going to be maintained not less than 25 to 30% kind of thing, kind of thing. Definitely 7% to 9% is a kind of energy gain is expected on fixed tilt, and specifically to single axis tracker kind of thing, 1P or 2P kind of solution, definitely that can touch beyond 15% kind of thing. And specific to one of our reference based installation, which is what we are having in Peru. So that is again with a kind of single axis tracker with 80%, 75% to 80% of albedo, where we had seen 22% of energy gain. So reference based installations are there to validate the same thing. But yes, we have seen some miserable days, specifically on the tracker aspect within our country. Hopefully that is going to be mitigated in coming days.
Yeah, okay. Thanks, Sai. So so the takeaway is like, yeah, we can presume that with the time to come, we can see further reduction in the delta, because definitely as far as cell is concerned, they are intrinsically bifacial as far as monopoc, as we say. So it is only time when this gap will be bridged, and then everywhere you will see only bifacial being installed as a call of the day. And second thing, as you rightly told, that yeah, we have a lot of like, there is a lot of history behind that. Okay, in Peru there's a good albedo, there is a yellow. So that gives a kind of confidence. But the most important thing is that wherever you are going to install, we should have a touch base. Like Ivan told that, yeah, there will be a pilot. So that is very, very important. So coming to our heroes, Arctech. So heroes of these days. So like as Sai gave Beton, that the history has to be improved. That is definitely there. So I have two questions. Maybe Ganesh or Herekar can take that. I was going through the presentation, and as we discussed earlier as well, about the tracker uptime, right? Tracker uptime, and specifically to the design considerations. When your stow angle to the maximum angle, as I understand, because typically Badla is 47 meter per second. And as I understand that at 45 degrees, maybe 1P and 2P, if you can correct me, that at maximum angle, it can sustain the wind speed of 12 to 13 meter per second, right? So we wanted to understand from you that what design considerations has been taken once you reach from at what wind speed it starts moving towards stow angle, and why the gap of the maximum design wind speed, which is 47, and the wind speed, which we name in tracker jargon as critical wind speed. So why this gap is there, and how much time does your tracker, or in general tracker, takes to move from the maximum angle to your stow angle, right? So I have two questions. First is about uptime and the philosophy of Arctech, to be particular about, as I told you, about SLAs, in what way they can ensure the uptime. And second question, as I asked, about the stow angle and the design and critical wind speed. Yeah. Maybe Ganesh can take, or
Yes.
Amit can. Yeah.
Yeah. So thank you so much, Sudhir sir, to put this question. So about the uptime, so basically in our tracker, we have provision to provide uptime warranty up to 99%. That is default. We have seen most of our competitors are not giving this uptime guarantee, but we are pretty much confident, and we have seen, because we have history of around last 10 years, and we are pretty much confident. That's why we are giving 99% uptime warranty. So this is the one thing. And second thing which you ask us about stowing angle. So we have two model, 1P and 2P. In 1P stowing angle is 30 degree, and 2P stowing angle is 0 degree. And if we can speak about critical wind speed remains same in both the tracker, 1P and 2P. That is around 12 meter per second as per 7-10. So if you ask us why we cannot design complete tracker with the maximum design wind speed, so see, we need to do some optimization, because we have seen if windy speed is always not reached at that certain level, there is no point to put extra steel on the tracker. So that's why we have seen most of the time windy speeds are within the 10 to 12 meter per second range. That's why we considered this 12 meter per second as a critical windy speed, and as soon as wind touch on that particular speed, tracker will start come back to stop position, and that will take hardly less than 5 minutes because motor is rotating 12 degree per minute. So that's again depend upon tracker are available at which angle, and based on that tracker will take time to come back to the stop position.
Okay, Ganesh. So like I have two offspring questions from the statements which you gave.
Yes.
First is about the 5 minutes, as you told. So I keep on asking many people in uh, geology or IMD kind of that like for the gust, which is because 47 meter per second is basically gust, which is a 1 second or 3 second gust.
Yes.
So it's a 3 second span, right? And
Yes.
we talk about 5 minutes. So
Yes.
I keep on asking that what is the like a scientific study behind it, that suppose the tracker is at as minus 45 degrees or plus 45 degrees angle, and as you told about 1p 30 degrees, so it's less, but 2p it is 0 degrees.
Yes.
So it needs to move from 45 to 0 degrees in 5 minutes. What is the probability that the wind speed will not cross the critical of 12 meter per second in this complete 5 minutes? That is my question number one. Question number two, again on uptime, as you are saying 99%. So what is the background work which Arctech has done to ensure that the uptime will be 99%, kind of like service chain, the spares maintenance, and their locations, the prospective locations all across India? Yeah.
Yes. So as Jason already mentions, we have warehouses in two warehouses already in operation, Hyderabad and Gurgaon, and another warehouse we are going to open in Rajasthan because we have a huge pipeline in Rajasthan. So these three warehouse we have, and that's why we are pretty much confident if any of the client needed any spare part that we are able to provide. So this is the one part. And second part, if you ask us about how we can cater this wind speed will not reach or that certain level. So we have seen earlier also, if wind speed start increasing, that will not increase suddenly because that's a different kind of provision, kind cyclone or cyclone kind of thing. So we have not seen that kind of experience. And if we are saying 12 meter per second, but there is a limit 10 to 12 meter per second. So as soon as wind reach on that particular level, tracker start moving to the stop position. So if you see it, 12 meter per second, so I am saying once wind speed touch 10 meter or 12 meter per second, tracker start moving to the stop position, and within the safest time, tracker will come back to the stop position.
Okay, so I think that we are reaching the closure of the discussion, and really thanks to all the panelists for giving their insights. So I think Sangeeta, if there is any questions from the audience, so that can be taken.
So attendees, if there is any questions from your end, you can unmute yourself and go ahead asking live questions to our session experts. We exactly have 3 to 4 minutes left.
Hello.
Yes, sir, please go ahead with your question.
Hello.
Yes, sir,
Am I
please go
audible?
ahead. Yes, sir, we are able to hear you.
Yeah. I have as we are discussing around the stow position of the stow angle of the 2p and 1p structure. 1p structure has a stow position of 30 degree.
Right.
I would like to know the stow position of 2p structure and why it is around 0 degree. because in wind tunnel study, we see generally around 0 degree, we have flutter instability and galloping effect.
Yes, so
Uh,
it's a very good question, Mr. Asutosh, if I understand correctly. So
yes.
basically, in our one-piece solution,
Ganesh, you are.
Sorry to unmute
sorry. So in one-piece solution, we have a single slew drive. So that means we have single fixed point. That's why in wind tunnel study, we found we must need to put tracker at 30 degree. But in our two-piece solution, we have multiple slew drive. That means
Okay.
maybe 2 or 3 depends upon the wind speed. We can put the 2 or 3 slew drive, and that will allow us to reduce the free spans. So
Okay.
if you can speak about the spans in one piece solution, span is around 8 to 9 meter, but in two piece
Okay.
solution, this span is hardly 5 to 5.5 meter. So automatically fixed point increase, and span will decrease, and similarly this cantilever also reduce. So this will give us
Okay.
the confidence to reduce the stowing angle. And from the wind tunnel test we carried out, 0 degree is the safest position for 2P.
Okay. I would like
I
to
have
add.
I have one more question. No one has discussed the difference of the cost of generation. For example, if it is 2 rupees now, so with the tracker as well as the bifacial things, what would be the cost like today? So that can we compare this?
So maybe Amit will answer you about the costing part. Amit?
Sure, sure. Hi, Mr. Verma.
Yeah.
In my presentation, I shown the difference in the capex cost. So there is, clearly I have mentioned that there is a decrease in capex by 11%. If you consider the bifacial with tracker and bifacial with the fixed tilt structure. So if you only compare the fixed tilt structural cost versus the tracker cost, then there will be around 40% increase in cost of tracker compared with the fixed tilt. But if you compare the complete BOS as well as the module cost, then you will find there will be a significant reduction in the overall capex, and tracker plus bifacial makes sense in this.
Okay. Thank you.
Okay, one question from my side. Like in the PV system, if we will do the simulation, then we will get like around 24 to 25% comparing with the fixed tilt of mono, with the like bifacial and tracker. But in India, as we know that there is a much diffuse radiation. So whether PV system is taking care all those things, because if we are going directly to the physics, then we can say that the difference between the generation is more than 30% as well, because in India the diffuse radiation is too much. So any of the expert like done the pilot project and get the results like monofixed versus bifacial tracker in India region, so that we will get the exact the benefit in terms of gain.
Yeah, I think I can take this question since this is also close to my heart. See, like PVSys, as I explained during the discussion, that is also on in the learning curve, right? So there is a software called Radiance from NREL, which is being touted that it provides better algorithm as far as this is concerned. So there are typically two algorithms which work as far as radiation movement is concerned. One is called view factor, and another is called ray tracing. Right. So what I believe that PVSys basically works on view factor, wherein the ray tracing algorithm is touted to be much better as far as bifacial is concerned, because you get the diffusion once you trace the rays from wherever it is coming here and there. So I still believe that PVSys is slightly, I will not say conservative or optimistic, not that accurate. I will give the right word. So therefore, it is important that, as like the co-panelists told, that it is important to get some kind of POC done to get the real feel of that, right? So this is my personal opinion. If anybody can add to it, maybe Ivan can add, or Amit can add, or Ganesh. Yeah.
I have a question to Amit. Like, am I audible? Hello.
Yes, yes.
Yeah, Amit, hi. I was going through your presentation, this CapEx comparison tilt versus tracker. So it was proved that you proved that the CapEx cost is lower if you bifacial versus fixed tilt, and keeping the AC capacity as 50 megawatt. So I wanted to see, like, is this capex cost based on what factor? Is it based on the DC capacity or is it AC capacity with
Yes.
relevant to AC or DC capacity?
Yeah. So in fixed system, I have considered the DC capacity overloading with the 45%. And with the tracker, I have considered the 12% DC overloading capacity to achieve the same generation number, which we are aiming with the fixed tilt system.
I have a question. Hello.
Yes, please.
I have a question to Mr. Ganesh, and even Amit can also be part of this. See, I heard there's another type of tracker which has come out in the market, which is into 2 axis, which is not moving into east to west, but also from north to south. Now, what do you think is going to be the effect of the bifacial modules if being installed on that particular tracker? Will it be much better?
So, Mr. Varun, if I understand correctly, you are talking about tracker with tilt solution. So basically,
no. I'm talking about a tracker which has got 2 movements simultaneously, east-west as well as north-south. These are simultaneous.
Dual axis, I think.
Dual axis.
We don't call it dual axis. Dual axis is totally a different tracker, like which is on a unipole and moving in all the directions, east-west, north-south, and then in a parabolic manner. Okay. Well, this is a technology which, I have developed in collaboration with IIT Delhi, which moves east-west and north-south simultaneously.
Okay.
Yeah. So what will be the effect of the bifacial module on this type of tracker? This is totally a new design which has come out into the market.
Sorry, Mr. Varun, but so far we have not developed this kind of product in our laboratory. And unfortunately, I'm not able to directly give you answer. So if you're really interested to know more about this, maybe you can send me mail and I will discuss along with my R&D and maybe we will give you some more input to you.
Okay. Well,
I think Mr. Varun, if I'm not wrong, you have put your pilot in Roorkee, right? Isn't it?
Yeah. Very right, Sudhir.
Yeah. So means so I think we had studied that if you remember. So I think as far as
you're from which company?
Excuse me.
You are from which company?
I'm from Hero.
Okay.
Yeah, I think we discussed. Right?
Yes, Sudhir. Yes, I got it. Yeah.
So I think I'd like to reply to your question as far as bifacial is concerned. As being explained by Ganesh and others, that the bifacial, I think in your system, you are fixing your south tilt changes on maybe monthly or seasonal basis, and east-west changes on basis.
Daily basis.
Okay, so from that perspective, only we need to see the quantum of the shadow, which comes because of the mechanism which is behind it. I think that is one of the factors, but that can be one of the better thing as far as once we go move much more away from Tropic of Cancer, like Badla, or even on the higher side. That can be once it sustains the high wind speed. So that is my reply on that.
Yeah, I think Mr. Varun, this is Ivan Saha from Renew Power. So hi. So so intuitively, yes, it should give you a benefit. However, as I said, any new technology needs to be evaluated in its entirety. It's not only about what bifacial module you put. It's also about the size of the bifacial module. Whether what is the total kilowatt per tracker that you can put, the length and etc. All of that, and then exactly calculate the benefit, not only additional generation, but I think overall the LCOE of it, that can be driven. But all these things can be actually tested only on a pilot scale, where you could have one inverter connected on this tracker and then get data and then compare it with a standard tracker or a fixed tilt, and then come up with confirm numbers basis which you can make further investment.
Okay, thanks. Thank you, Evan.
Thank you.
Sir, I'm Rajesh Kumar. Can I have a question, please?
Yes, sir, please go ahead.
Yeah, I'm from Indo Wind Energy. We have a 1 megawatt solar project done in 2012 in Guntur. Actually, that time it was the solar industry was in nascent stage. So we had only 210 watt peak modules available at that time. So we put the 1 megawatt DC plant there, and within 3 years, the generation was drastically lower, and most of the modules have gone bad. Hotspots and all those things, PID, all effects were there. So now we are looking to see whether we can replace it with the bifacial panels, because I have gone through the bifacial panels things in the Wari site, and we had been in discussion with them, but the sizes of that bifacial panels are very high compared to what we have had in the 210 watt peak. So whether we may have to change the entire lot of for nearly 5,000 panels we have installed for that capacity. So now with the bifacial panels, I feel that we can try to do it, but only it's a fixed module. It cannot be made into a tracker system. So whether any guidance can be received for having a look at it, and we have a central inverter of ABB, and now bifacial, you are saying that it will, with string inverters it will be better and cost effective because of the DC cabling and less DC cabling, and these sort of issues are there. So whether the cost LCOE, as of now we are getting generation nearly only 60% of what they expected, but with the change, with the prices coming down now, I feel that we can take a chance of replacing the entire modules with the bifacial system, and can try to improve the because the other balance of systems, everything is available. So only the panels need to be changed, and with that, whether the project can be at least come to the level of expectation and the LCOE. Anybody can guide me, sir. Thank you.
Yeah. Hi, Mr. Raja. This is Sai Charan from Jinko. So we specifically understand your concern of how exactly the old generation technology module is not performing well for you. So even if you're trying to go with any kind of existing upstream main products of any of the module manufacturer, you find the same difficulty, because there always comes, well, if you're trying to go with a kind of fixed tilt mechanism, the pitch hole position of the existing module,
correct,
of your old module, or
now we have changed some of the modules from 210 to 270,
right?
But
they will not
that we had to do the alterations on the mounting system,
right? So anyway, it is not going to match. So for that thing, we definitely can help you on that, specifically on the module part, or we can collaboratively work along with Arctech as well. In just if you can provide us a kind of detailed any kind of audit report of your plant, definitely we can work collaboratively with you on this particular aspect. And probably since it's an old power plant which has got much better tariff, definitely bifacial with tracker kind of solution makes much more sense, since it is located in Andhra Pradesh.
Yeah, that's why I was evaluating the cost benefit analysis and seeing whether we have done a study on that by through TUV, as well as we have got MNRE people coming and seeing the deterioration in the plant and allowed us to make the changes. So we have those reports available where the hotspots have been identified, and still Again, though we have changed nearly 2,000 panels, again another 2,500 panels are there which needs to be modified.
Yeah, we
So
can
that
discuss
is the
offline.
reason why we thought.
Definitely, we can discuss offline. You can share us the audit reports along with us and Arctech, so that we can see how best this can be.
Yeah. Can I have your email ID, please?
Yeah, we'll provide you through our organizer.
Yes, I will put it down in chat box. Okay.
Okay. Thank you.
Sangeeta, one more small clarification from my side, that the Sudhir mentioned initially that the tracker being a mechanical piece of equipment, gearing and motor, etc. Now, and the life, etc. Have you, while comparing the cost, etc., have you considered the outage of this tracker arrangement at some point of time, or when it gets stuck up, for example, if there is a failure, then what happens? How it is affecting life, etc., and the cost, maintenance cost, etc. Had it been taken into consideration?
Yeah, I think Ganesh or Amit can reply on this because it's pertaining to your product.
Yes, let me answer this. As you know, the system get failed. So before anything happened to the site, maybe because of failure of your screwing drive or electronics communication boxes, or maybe because of loss of communication box. So we have one software and one application which we provide along with our tracker. So the buyer can install in their SCADA room as well as in their system, and they can monitor the performance of it. And whenever there is a failure happens, so the O&M team will get alarm, and they will easily identify which rows of tracker is failed because of what reason, and they can only pinpoint the problem and solve that. They no need to do it again, due diligence and identify what was the problem in the tracker. I hope I rightly explained to you.
Yeah, okay. I think maybe we can discuss more about it.
Sure. You can write down to me on my email ID as I mentioned in my presentation. Once I write in the chat box, you can send email to me, then we can discuss offline.
Okay, thank you.
All the attendees, with this, we have come to the end of the webinar. On behalf of First View Media Ventures Private Limited, I would like to thank all the key speakers for your valuable insights. Thank you all the attendees for joining us today. I would like to thank our exclusive partner, Arctech Solar, for joining us today. With this positive note, we would like to end today's webinar. Thank you.
Thank you so much, everyone.
Thank you.
Thank you. Thanks, everyone.
Thank you so much, everyone.
Bye.
Thanks, everyone.
All the panelists, thank you very much.